So welcome everybody, my name is Nicola Martino, and today I will give you an introduction session on a new set of APIs that are made available for Crosswork network controller that focus on element management functions. Okay, let me represent this slide again. So Paolo already presented this slide, so let me start the conversation reminding you what the element management functions are, as also John mentioned. So we started with just the SDN controller for AP network, and then we added on top new capabilities that focus on element management functions. So this component in Crosswork network controller delivers inventory, fault, device upgrades, and performance management counter collection. As you can imagine, all those capabilities are made available through the Crosswork network controller graphical user interface, but also through the APIs. And this is the topic of today's session. Those are the areas that are covered by the API. So we have a large set of APIs for inventory, for alarms. We have different types of notifications. So we have RESTCONF based notifications, but we also have the possibility to integrate with a Kafka messaging bus and their stream inventory or alarm notification on Kafka topics. We also have device level counters collected and made available in different ways, and we also support device software upgrades. Now, for time constraints, I cannot cover all areas, but I will focus mainly on inventory and alarms, covering also the notifications, RESTCONF notification option. Okay. Now, if you look at the DevNet page, there we have all these APIs already documented with different section for the different functional area, with those all API call described with the resource endpoint, the method, the filter, the supported encoding, and also the attributes. Now you may wonder, so why do I need with session? So it's already everything is already documented on DevNet. So why I need this session? So when people get to the DevNet page, then they start asking themselves, so, okay, cool, I have a lot of API described, but how can I really use those API? What are the typical use case? I want real examples. And sometimes people come to me and say, you know what, I start testing those API, but I don't understand the output. So the target for this session is really going through use cases, giving you examples, use cases, and also giving you some details that are not yet available on DevNet. So this is really the target for this session, giving you practical example on how to best leverage those APIs. Okay. And this is where I said that in this session, we also have additional information that are not available on DevNet yet. So let me start with the concept of fully distinguished name. So basically, the FDN of fully distinguished name is the unique identifier for every inventory object in the system. And it's the typical output you get when you query those APIs, and can also be used as a filter option on some of those API calls. So the FDN, it's a string, and it's typically made of a sequence of type and value, where the type is fixed, and you see here the values, while the value is a sequence of attribute and value. But the next slide will clarify the concept better, because maybe it was too complicated. So let me give you some example. So those are some FDNs. So we have FDN for nodes, equipment, physical connect, dimension point, and so on. And as you can see from the example, it's a sequence of type and value. So we start with, for example, for the node, we have Cisco EMS as type MD, and then the ND or node type is followed by the device name. And as you can see for the other examples, they all start with the same two types, MD and D, and then followed by the either the equipment type or the termination point type with their own attributes. And the attributes can be concatenated, as you can see, for example, for the interfaces where we also have the layer rate. It is very important. Using the filters, so when you run the Query API, so the response can be large. So there can be multiple objects returned by the API. So what if you want to filter to just the entities that you are interested rather than the whole set of objects, and also if you want to reduce the workload on the system. So we have filters, we have system filters, and we also have on a per API based filter. Those are in the form of parameter equal value, and you can concatenate filters by using the ampersand character. Now, two important filters that are not described on DevNet are the start index and max count. So when you query the API, the output is coming back with the batch size of 100. That means that if you have more than 100 elements to be returned, you need to do some paging. So the start index is exactly what is meant to do. So you can do paging on a 100 base, but we have a more clear example coming up in the next slides. The other one is the max count. So as you can imagine from the name, the max count reduce the result output to X number of entities or instances. And what I usually do is I use max count equals 0 to test the API behavior and to see the typical output. Now, this is an example of a get where in the either section of the output, you have first index and last index, and you see last index is 99. That means that most probably you have other objects returned by this API, and you need to do some paging. Now, appending to the URL start index equal 100 or 200, the other, and so on, as we have in the top right part of the picture. This way you can start paging, and only when you get the last index returning a value lower than 99 on 199 and so on, that means you have the full output returned by the API. Now, inventory data and alarms. So as we said, we will focus on inventory and alarms. There are a lot of APIs for each functional area. So I want to focus rather than exploring all possible API call. I want to only focus on the main API call and give you example and also example on to use them, and also example output because those are the basics for the alarm inventory API usage. Then once you understand how this works, then you can start moving with others, like for example for the alarms we have other set of API that focus on the alarm life cycle, like acknowledge and acknowledge, clear, and so on. So but you first need to understand how those main API call can be used. Let me start with the non-inventory. As you can understand from this slide, this API is meant to return attributes like node name, IP address, and so on. The most important is the equipment list attribute. This returns a list of inventory objects in a hierarchical way, but we will explore this in a few slides. So here we have a list of filters that you can use. In the example we have on the bottom side of this slide, we have the API, the endpoint with also the filter highlighted in orange. Let me focus on the other two examples because we will cover the first one in a couple of slides. So the first example is where you focus on a single device and you want to return all inventory for that device. And the next example, the last one in this page, retrieves all inventory for all platforms of a given type. So those are the typical use cases for this API call. This is an example output where we see a long list of attributes like the device name, the device platform. As you can see here, we have the FDN in the center of this output. Then we have a software version and so on. All those attributes, by the way, just to remind you, are described in on the DevNet page. This is where we mentioned the equipment list attribute. As we said, this is a list, and when you expand the list, you get access to the full inventory list. And as you can see, and as we mentioned before, all those objects are referenced by their FDN. So it's important you get used to this term and how to read that those strings. Now, as we mentioned before, the output also provides the device containment in a hierarchical way. What does it mean? So the discovery process leverages the entity map for discovering the physical asset, and typically every object in the inventory list has a referent index that points to its parent and provide the list of leaves. So in the same way, when you look at the API output and the inventory list, every object in this inventory list, of course, expressed with their own FDN, has a referent index to its parent, so the contained equipment, and parent the contained equipment, and also pointed to the list of containing equipments, also in this case expressed in form of FDN. But next slide will clarify with an example. So here we have the equipment list. As you can see from the example, the second object from the list is rec0, and it has a couple of attributes: containing equipment and containing equipment. And the containing equipment is the parent of this object, while the containing equipment is the list of leaves. In this case, is only pointing to a single element in the output. And as you can see, the first object returned by this list is indeed the parent of the rec0 root processor object. Yeah, we mentioned about a filter that I've been mentioning before, but in this example will be more clear. So as we said, this API can be used to retrieve the device inventory list, but you might be only interested to retrieve from the network just basic information like device name, IP address, software version, and so on. So you might be not interested on the whole physical inventory. So there is this filter that is only available for this resource endpoint, where you can completely filter out the inventory list and only focus on the basic attribute. This will help a lot on alleviating the workload on the system when querying through this API. Now, locate equipment. So the previous API call, the typical use case is starting from a node or a product family, retrieving all the inventory for that node and so on. This API call, the typical use case, is working on the other way around. So starting from a given equipment object, retrieving from the network where that object is. So it can be used as a search engine. Also, in this case, we have the list of available filters and examples. So the first example is retrieving all 10 gig interfaces this might be more or less useful depending on use case. The next example is retrieving all SFPs of a given matching given product ID. And again, this will be the next example. Or you can filter by the description where you look for a specific, I don't know, for example, root processor card in the entire network. Now, let me give you the example for retrieving based on a product ID. So this is the output where you see inventory informations like the product ID, the serial number, where this pluggable is located, again, in terms of FDN and so on. Termination points. This returns all, let's say, ports. Let's be clear, ports. Well, of course, we comply with the TMF standard, so that's why you see those with those the ports reported with those with this naming convention. So we have a physical termination point, floating termination point, and connection termination point. Where the physical termination point, to give an example, those are the at least in CNC, those are the optics controller returned by colored or gray optics. The floating termination point, those are logical termination points. And to give you an example, those might be, of course, the Ethernet interfaces. In those cases, those will be termination point anchored to a card, but there will be other termination point that will be not anchored to card. For example, loopbacks, those will also be reported by floating termination points. And finally, connection termination points. Those are a subset of the floating termination points, basically termination points that are used to terminate, for example, IP link or optical link. But I will give an example in a couple of slides. Also, in this case, we have the available filters and also examples. You can filter by all floating termination points, or you may filter by all termination points available on a given node, or like the next slide example, filtering on all 10 gig interface available on a given node by adding the layer rate, as you can see from the last line from this slide. And this is an example of some, maybe one example that I forgot to mention. You can also pass as a filter the termination point FDN. So this can be useful if you are not listening for notifications, because if you want to have your tool that connects to the API always updated, you either listen for the notification, or if you don't want to listen for the notification and you want to have an updated information on a given object, you can pass straight the object FDN as filter option. So, and as for the previous example, here we have all attributes for the termination points, like the Ethernet name, the description, speed, and so on. And as you can see from the example, one of the attributes is the IP address. That means in this case, this output is listing this port as a floating termination point. But if you filter by connection termination point, this port will also be listed as in that list. So basically, the connection termination point is a subset of the floating termination point. Retrieving alarms, so you can retrieve active and cleared alarms. So by default, you get all alarms returned by this API. So if you want to focus and returning both system alarms and also device alarms. If you want to filter just device alarms, you need to apply this filter reported with in green, so alarm type device, and then you can add the typical filters like adding the node name or an FDN or a termination point with the layer rate, or simply the severity without any other filter. So that to retrieve just the active alarm. So again, remember that by default you also get the declared alarms. This is an example where you have the description, the attributes like the description, severity, the different timestamps, and also in this case we have an FDN. Remember that the FDN relates to inventory objects, so you don't have FDN for other things, like there is no FDN for an alarm. Notifications. We have two different types of notifications. We have connectionless and collection-oriented notifications. When you use collection-oriented notification, you can pass filters through the URL, filters for example, for the objects and so on. While for the connection-oriented, for the connectionless, whatever is required for the retrieve of for the subscription is passed through the post payload. And this is the list of resource endpoint. We have 4 for connection-oriented, 2 per topic, so 2 per alarm and 2 per inventory, and and 2 different basically depending on the encoding. While for the connectionless, we just have 1 resource endpoint. Here we have an example of a filter format for the connection-oriented. When you subscribe using a connection-oriented, the connection-oriented option, the connection is kept on, and the system will stream inventory and or alarms notifications until the client disconnects. And by the way, we have a keep alive bit that check for the connectivity every 60 seconds. On the other end, when you do connectionless notifications, the session is kept on, and the system will stream notification until a specific delete command has been issued. So there is a list of, let's say, life cycle commands for the connection subscription. So where you can monitor, you can delete, and so on. And here we have an example of filters for the connectionless subscription. So here we have an example of filters for both connection-oriented and connectionless. Bear in mind that for the subscriptions, we have filters based on product family, product type, severity, and device unique identifiers. This is a complete example for the post payload, where we have the client IP address where you need to stream the data. We have the topic, in this case is alarm, but can be inventory. We have the encapsulation, and followed by the list of filters. Here we have a couple of notification examples. We have to mention here as you can see, the topic is inventory and the operation is create. So that means that this specific object has been just inserted on a device, and all attributes are more or less the same as you will get from the query API. This is an example for the alarm notification. In this case, the topic is alarm and the operation is modified. That means this alarm was already present in the system and it got updated by this event. Last slide for this session, and I'm perfect on time. Last slide of this session. So we have testing client that you can use to test connectionless and connection-oriented notification. Those are available on GitHub, and we have different binary for the different software versions. And with this, I conclude my session. Back to you, John.
Thank you, Nicola. That was terrific. I mean, this is a developer conference, and you provided a lot of excellent information on how the system can be used to abstract and provide, these APIs for element management. And what's exciting is, it is a multi-vendor capable product. So, we can really see how this could be used
Absolutely.
by operators. So I do have a couple questions, and definitely we have some developers on the line. So what happens when an API call does not have any data to return, or there's no match with a used filter?
Okay, good question. So you might remember we have a part of, the output contains an header. So that either contains first index and last index. When there is no matching filter or there is no data at all to be returned by the API, in that case, the last index will return -1. So by convention, that will be typically any integer, but when it returns, you can basically implement a check. If the last index is -1, that means there is no data to be returned by that API.
Okay. Can I filter alarm notifications for a specific alarm type?
For a specific alarm type, no. Unfortunately, there is no subscription per alarm type. You only can filter by severity. So you have to filter by severity or by one of the other filters that I've been showing before. And then if you want to put additional filters, that logic needs to be implemented on the client side. So you need to put the filter on the client itself, at least today. So we might implement additional filters in the future, but those are the list of filters available today.
Okay. Yeah. So if that requirement is important, for the customer that asked the question, please let us know.
Paula.
We'll prioritize it.
Do you have a delete? We'll give Paula's email address.
Yeah, Paula. Do you have a delete operation for the RESTCONF notification?
Sorry, can you come back?
Do you have a delete operation for these RESTCONF notifications?
Delete operation, not today. We are coming up because, for example, if you think about alarms, so there is no really a delete operation for alarms, because you typically get updates. So the alarm can raise, clear, and then raise again. So there is no a delete operation for alarm. But we noticed there is a need for the delete operation for inventory. That is coming in 7.1 or one of the upcoming releases. Thank you for the question,
great.
John.
Yeah. And I think we're a couple minutes ahead of schedule, but I think one important point, Nicola, for folks that may not have understood this, is that the Crosswork Network Controller comes in, an essentials package and a advantage package, and the advantage package, has a lot of traffic engineering, service provisioning, and other things, where the essentials is more around these element management functions. So I guess, what you presented here is really some of the things that are part of the essentials package. So if a customer only wanted the element management API functionality, they can just purchase this package for that. What you showed here today, is that correct?
Correct. So the essential package is the first and basic package that you can install on top of the Crosswork Network Controller infrastructure. There you have the advantage that delivers the use cases you mentioned before, but Bear in mind that before you can install the Advantage package, you must install the essential package first. So that basically translates every time you leverage or you want to leverage the features that more focus on the IP domain controller side of the product. In any case, those element management capabilities will be there anyway. So the Advantage does not prevent the customer to also leverage the essential, in short.